Yes, a question asked in the previous JE is which of the following is not a benzenide structure? Before going to the discussion related to the benzenide, one thing is compulsory to be known prior to that of benzenide structures is aromatic. Aromatic compounds are divided into two categories. Some of the aromatic compounds are said to be benzenide and some of the aromatic compounds are said to be non-benzenide structures. Benzenide compounds are those compounds, those of all are aromatic in which benzene-like structure if it is present, then that is known as benzenide. Aromatic compounds, those are not consisting of benzene-like of structures are said to be what? Non-benzenide structures. Whereas benzenide as well as non-benzenide, both are of aromatic in nature. Whereas the options provided for us for the discussion to say summing them as benzenide or non-benzenide is given by, and the options those are given by naphthalene followed by aniline. This is tetracyanooctane followed by, this is another one, 3 benzene rings combination. Whereas this particular compound, left ring and the right ring both are of benzenes and it is aromatic, it satisfies all the rules. The total number of electrons will becomes equal to 3 plus 2 5, 5 into 2 10, 10 will becomes equal to 4 into 2 plus 2. Hence it satisfies cyclic nature, conjugation and the planarity, and the total number of mobile electrons are of 10 and it is consisting benzene type of system, hence it is benzenide structure. Hence this structure is benzenide in nature. Whereas the second one, here also benzene like ring is there followed by cyclic conjugation, planarity, total number of electrons is equal to 4 into 1 plus 2. It is also benzene type of system, hence it is also benzenide. Whereas this particular compound, cyclooctatetraene, whereas the total number of it is, as we mentioned in the last questions also, it is not having planar shape, it is tubbing shape. It is non-planar in nature. As being it is non-planar in nature, it is non-aromatic. When it becomes not an aromatic compound, when it becomes not an aromatic compound, benzenide and the non-benzenide discussion doesn't come. Whereas in this case also, this interior of the ring, there is one carbon. This carbon is also associated with the hydrogen. It is sp3 hybridization. It is not present in the plane. Whatever the interior portions of the ring system are there, those of all are to be present as a part and part of plane, but it is not present as part and part of plane. Out of plane implies it is also becomes non-aromatic in nature. So therefore, out of given 4 options, 2 are aromatic and are consisting benzene type of rings in them. Hence these 2 are benzenide structures. Remaining 2 are non-planar. Non-planar implies non-aromatic. As being these are non-aromatic in nature, there is no question of benzenide as well as the non-benzenide. Hence this option, that is cyclooctatetraene and the other compound, both are non-planar. As being these 2 are non-planar in nature, these are non-aromatic. As being these are non-aromatic in nature, these are not considered as benzenide structures. Hence these are the compounds which are non-benzenide compounds in nature. Write the product and the intermediate of the following transformation, and the reaction is given by benzene on reaction with propyl chloride in presence of anhydrous aluminum chloride. It is a substitution reaction, and in this reaction electrophile is generated with the help of Lewis reagent. Hence this is said to be Friedel-Crafts. This is Friedel-Crafts alkylation reaction. This reaction is Friedel-Crafts alkylation reaction. Whereas in the beginning, whatever alkyl halide propyl chloride is there, this propyl chloride is allowed to react with electron deficient compound AlCl3. Technically this AlCl3 is known as Lewis acid. As a result, the day2 bond formation takes place between the chlorine as well as the AlCl3. Like this will becomes minus, now this will becomes plus. Whole it is a neutral. Now this sigma bond is completely broken because chlorine becomes more electron deficient. That results into the formation of primary carbocation, that is propyl carbocation formation takes place. This propyl carbocation, whatever is formed is primary, becomes unstable, hence it involves in rearrangement to generate stablest carbocation compared to primary. Secondary is found to be more stable in nature, so therefore isopropyl cation, what we can say this one, isopropyl cation formation takes place as the newly generated electrophile propyl cation modifies to stablest cation, that is isopropyl cation. This is acting as stablest cation, this is acting as electrophile. This electrophile electrophilically substitutes over the benzene system. Here I am writing the product in the box, whereas this is benzene. On this benzene, 3 double bonds are there. This on reaction with our electron deficient compound, that is isopropyl cation, electrophilically benzene attacks over here. The place where it attacks, where from it attacks, from that carbon hydrogen is got replaced. Suppose if I claim this is the place where isopropyl got is substituted, at remaining places hydrogens are present. From that place where this benzene is making an attack, from there the hydrogen is got replaced. Hence the final product formed is isopropyl benzene formation takes place, is the final product. Product of the reaction is isopropyl benzene. The intermediate is originally the stablest intermediate is said to be the nominal intermediate. That intermediate is isopropyl cation is the intermediate, and the product is isopropyl benzene is the final product of the transformation. For this, the justification is once again propyl chloride on reaction with electron deficient compound of the same variety of the halogen converted to day 2 bond formation results into AlCl4. AlCl4 left from the system as AlCl4 minus. As a result, primary propyl cation formation takes place. This involves in rearrangement to generate a stablest cation, that is isopropyl cation, that is N-propyl cation is transformed to isopropyl cation. As isopropyl cation is electron deficient, as electrophile, benzene makes an attack over the electrophile of newly generated isopropyl cation, thus results into the formation of isopropyl benzene. This isopropyl benzene is the product, and isopropyl cation is the intermediate of the transformation.